Hello, everybody. Thank you for joining us today. Today's webinar is going to be focused on making it real. How do you get to your prototype? What are we looking for? How do we get to your digital twin? What are we looking for? And demonstrating your solution. Next slide, please. So our agenda for today, we'll just do a little bit of welcome and housekeeping. We'll do a bit of a challenge refresher. Webinar 1 covers our whole challenge in detail, which you can find on our website, which we'll share shortly. We'll talk a little bit about why does recycling on the moon and Mars matter to NASA, and in what context does it matter to NASA? And then in this challenge, there's two things that solvers can deliver: prototypes, which all solvers have to deliver, and digital twins, which is optional. So we're going to go into a lot of detail on both of those to help you understand what we're looking for and what they are in general. And then we'll have a conversation with a past solver. So how do you actually get this done? How do you balance life, work, finances, hours, etc., to actually get this done? So we have on the webinar today a past winner of one of our Centennial Challenges. We'll have some Q&A, and then we'll just give you a few reminders going forward. Next slide. So some housekeeping. This is set up as a webinar. That means you cannot communicate with us or with the other participants. However, you are able to ask questions whenever you would like using the Q&A function. So you'll type in those questions and we will answer them. We can only answer questions that are submitted in English. We are unable to answer any questions that are not submitted in English, so please submit all of your questions in English. We will not be answering any questions until we get to the Q&A section of this webinar, but we will be answering as many questions as we can at that time. Please remember that all answers that we share today are accurate and current as of right now, when this webinar is being live streamed, which is September 24th, 2025. Going forward, some of these answers may change between now and when you view it, if you're watching a recording of it. So in order to get the most absolute up-to-date information, always go to our lunarecyclechallenge.ua.edu website and read all of our FAQs. That website is the place for you to get all the most recent and detailed information on the challenge. All relevant questions from today, and also any relevant questions that we don't get to during this webinar, we will turn into FAQs and post on that website. Again, on that website, you can find the rules, FAQs, recordings of past webinars, and other resources. And that website is lunarecyclechallenge.ua.edu. After the webinar, if you have any questions that were not answered in our FAQs on the website or by other materials on the website, or were not answered in this webinar, please feel free to reach out to us at this email address, lunarecycle@ua.edu. That is the only channel where we can respond to any questions. If you use any other channels, personal emails, LinkedIn, Twitter, Facebook, Instagram, whatever, we are not able to answer any questions there. You must send your questions to lunarecycle@ua.edu. Next slide. So we have a great group of people today. There's a lot of us on this call today, but we want to make sure you have all the information you need to know that you can be successful in this challenge. So on this call, we have Jennifer Edmondson. She's going to give you an overview of the NASA context and why it matters. We have Elisa. She's our challenge rules lead, so she'll be there to answer questions. We have Savannah, who's our comm strategist. She'll also be there to answer questions. And then we have three folks from Space Factory, Connor, Leo, and Austin. They were past participants in a Centennial Challenges and won it. So they're the ones that are going to help you understand what it means to be a participant. Then we have Annie and Ray, who are going to talk to you about our prototypes and what we're looking for and what is a prototype and how does NASA use prototypes. And then we have Rodney and Tom, and they're going to focus on the digital twins. What are we looking for there? What is a digital twin? And how can you participate in that piece of it? The LunaRecycle Challenge is a 3 million two-phase competition focused on the development of solutions that can transform trash into useful feedstocks and end products on planetary surfaces like the moon and Mars. We are currently in phase 2 of this. Phase 2 is a 13-month challenge. We are looking for prototypes and digital twins, and the phase 2 prize purse is up to $2 million. Again, all detailed rules can be found at lunarecyclechallenge.ua.edu. Next slide. So some highlights. In phase 2, you must submit a prototype solution. However, digital twins are optional, though we think you're going to want to submit a digital twin because it unlocks a lot of additional prize purses that your team can win. So this is different than phase 1, where there were 2 tracks, where you had a prototype track and a digital twin track. Here, we have 1 track where the prototype solution is required and the digital twin is optional. Phase 2 is only open to US teams. This is also different than phase 1, where it was open to both US and international teams. For any questions on eligibility, please visit our website. It will tell you how you can participate and if you're eligible to participate, and if you are foreign national, how you could potentially participate in this challenge, even though it's only open to US teams. But please read those rules first and the legal requirements and the eligibility before you start sending a lot of emails on questions. All the answers are there. This phase 2 has 2 rounds of competition. There's a milestone round and a final round, which we'll get into in a little bit more detail in a moment. And that final round culminates in a live demonstration at a centralized location. This is going to happen in August of 2026. The location is still TBD, but we will let participants and solvers know as soon as that is locked down. That live demonstration will allow you to run your prototype through multiple iterations of it to see it physically doing the work it's supposed to do. You will also have the opportunity, if you choose to submit a digital twin, to run through that with our judge and evaluation team. An important piece here, this is about recycling on planetary surfaces. However, we don't expect you to build a facility here that replicates planetary conditions. So your prototype solutions should just be designed and built for Earth ambient conditions, not lunar or Martian conditions. Again, please look at the detailed rules on our LunaRecycle challenge at .ua.edu. Next slide. So as I mentioned, this is 2 rounds. There's a milestone round and there's a final round. We are currently in the milestone round. Here, you will submit and be judged on a preliminary design of your solution. Up to 20 finalist teams will be chosen to move on to the final round. And in that final round, teams will submit a final design and demonstrate their hardware and their digital twin, if they choose to do the digital twin, at a live event. Next slide. So here's just some key deadlines and milestones. The current milestone you should have ingrained in your brain is this January 22nd, 2026 at 4:00 p.m. Eastern. That is when your milestone round submissions are due. That is also the deadline for registration. However, registration is currently open. And on October 1st, you will actually be able to start submitting your solutions, but everything must be submitted by January 22nd, 2026. Next slide. So I mentioned this earlier, but if you have any questions on eligibility, we know we get a lot of questions in all of our challenges on that. Please check the rules. Everything is outlined clearly and in detail in those rules. Next slide. So that's it for the refresher. I'm now going to hand it over to Jennifer, who's going to give you the NASA context and why it matters. Thank you.
Hey everyone, I'm Jennifer Edmondson. I'm the acting program manager for Centennial Challenges. NASA is truly excited about the LunaRecycle Phase 2 challenge because it addresses a lot of the things we've been talking about in terms of our budgetary and mission requirements. In general, NASA is seeking solutions to make exploration more economical and efficient while providing a safe and comfortable environment for our astronauts. And this is why the LunaRecycle challenge matters to NASA. Next slide. With longer term human operations, trash management, including recycling, will play a critical role in reducing the need for frequent resupply and in making the most of what's already on board. NASA is interested in reducing the overall mass of things sent from Earth because it is so expensive to fly items and humans to off world destinations. And humans tend to be great consumers of things. In fact, a crew member of the International Space Station can generate over 3 pounds of trash per day. Over time, that can equate to a few $1 million worth of material that was launched from Earth that just becomes trash after it was used by the crew. We're trying to change that trash into usable items and reduce the overall amount of flown items that ultimately become unusable trash. If we can convert even a fraction of that 3 pounds of trash into something like a new fork or a new washcloth, that would help NASA maximize the utilities of things that we send from Earth and reduce the overall mass of material sent from Earth, which can save a lot of money. Next slide. Converting trash into useful resources can also support broader goals like in situ manufacturing and crew self sufficiency, enabling missions that are more efficient, cost effective, and less reliant on Earth based logistics. And this is one of my favorite pictures taken by Apollo 8 astronaut William Anders as our home, Earth, rose above the black and gray surface of the moon. The photo, which is encaptioned Earthrise, brings home the message of how precious our world is and how far away it is, even from the moon's surface. It took 3 days for Apollo crew members to reach the surface and 3 days to return them to land safely back on Earth. And that's a long time if you have an emergency. Any crew, even those on the International Space Station, which is only roughly 250 miles from Earth at any given time, need to be self sufficient to a large degree. And it's a lot easier to get supplies to the space station than it is to the lunar surface. One of NASA's programs to help with emergency or on demand needs for items is in space manufacturing. The payloads under development can produce things like gears, critical system parts, and tools to help crew members whenever these items are needed. Next slide. NASA's Moon to Mars architecture highlights reuse and responsible use as key tenets of long term mission success. What this means is the ideas of reuse and responsible use keep coming up in discussions with stakeholders. That's why maintainability and reuse are specifically called out as recurring tenet 5 within the architecture document, and responsible use is recurrent tenet 6. Tenet 5 specifically states maintainability should include a process to dispose of or reuse systems or selected system components upon completion of their primary mission. Tenet 6 asks for protection and preservation of landing sites and minimizing potential contamination of sites, such as with a large landfill. This lunar challenge seeks to minimize the trash buildup on the moon and convert trash into treasure to be used later as a new needed item. Next slide. NASA's Space Technology Mission Directorate, Science Mission Directorate, and Exploration Systems Development Mission Directorates have taken an interest in economically sustainable practices for long duration missions to the moon and Mars. This image was taken by astronaut Eugene Cernan of Harrison Schmitt standing on the moon by a house sized boulder during the Apollo 17 mission. Imagine if that boulder represented a pile of trash on the moon, and that trash pile could be used as a resource found in place or in situ. That's a lot of available material. We want to keep planetary landfills to a minimum size because landfills and waste management take energy. The smaller amount of materials that ultimately become trash, the better, and the more economically sustainable human space exploration becomes. And that is why this challenge is so important and why your prototypes and digital twins can help revolutionize the way trash is managed off Earth. Next slide. Additionally, recycling has been called out specifically in publicly released documents like the Space Technology Mission Directorate Shortfalls and the Science Mission Directorate Biological and Physical Sciences Decadal Survey. Both documents represent inputs from large communities of technology developers and users, scientists, and engineers. In this image, can you see the person on the International Space Station hiding behind the materials you could use to make new things? If so, then, next slide. Will you help us design and build the future? Thank you for your time. And with the next slide, I'll hand it over to our prototype head judge, Annie Meyer, to discuss what the team is looking for in prototype submissions. Thanks.
Hey everyone. All right, nice to be here with you today. We can go to the next slide. So I'm Annie Meyer from Kennedy. I'm also here with my colleague Ray Pitts. We are both technologists who have done a lot of development with hardware and testing and how we can infuse work into the future of these lunar and Mars missions. So if we go to the next slide, you're all probably fairly familiar with the TRL or technology readiness level scale that NASA has. So TRL 1 is the birth of an idea, the thought, and as you climb the TRL ladder, you are putting it through the rigor and the testing to see if it can finally get to TRL 9, which is the actual system that is flight proven. And that is the end goal for most of us, right? You want to see your hardware travel through lab testing and go all the way up to flight. If you go to the next slide, there is this, as you're climbing along, trying to get to that TRL 9, a TRL valley of death. And technology development involves a lot of failures along the way. Different scale up and environmental factors make things more and more of a challenge during this TRL journey. So the road to space is rich with successful prototyping, but then lots and lots of failures along the way. If you go to the next slide, this is something that NASA describes as hardware and how it's traveling along the TRL ladder. So if you are already at breadboard, brassboard engineering unit, you're making your way through the labs and through demonstrations, and then you get to prototype. And finally, qualification unit, protoflight, and flight unit. These terms, I didn't make them up. They're actually from, if you go to the next slide, NASA has a system engineering handbook. And so they actually have very specific definitions for each of these types of hardware. They're not just terms that we at NASA throw around. So to give you the definition of prototype from the system engineering handbook, I'm going to just put it on the next slide for you. It basically needs to have the form, fit, and function. So if you go to the next slide, the prototype unit demonstrates the form, fit, and function at a scale deemed to be representative of the final product operating in its operational environment. That's what NASA says is a prototype. And a subscale test article provides fidelity sufficient to permit validation of analytical models capable of predicting the behavior of full-scale systems in an operational environment. So this prototype is used to wring out the design solution so that we can learn from it, we can get feedback, change things, and change things on the ground. Typically, we're attempting to buy off buying off there's also requirements along the way. So attempting to buy off a shell requirement on a prototype is not acceptable. It is usually completed on a qualification or a flight or more final controlled unit. So the point is you want to make your mistakes here, and you want to learn from them at the prototype unit, because your next units are usually what are going to qualify you for flight. So it's a really good learning phase. It means you kind of left that initial valley of death with the TRL climbing, and you're on your way. You're aware of some of the challenges you're going to face toward more relevant environmental conditions in the future. And if you go to the next slide, that was the NASA version of a prototype. If you go to Agile project management, which is often used more on the commercial side or even academic side, prototypes are supposed to be quick and preliminary iterative models where you can fail quickly, you can visualize ideas, are they going to work, get feedback. And when you have a lot of money, you can make a lot of prototypes and fail faster and make a new one quickly. But they're not the final product, and it's again meant to test functionality, explore the design, and confirm user needs before committing to a full-scale development. So all of that is what we are looking for here, because if you go to the next slide, by the time we are going to send things to the lunar surface, maybe it would be your design, as it travels along this TRL ladder, these astronauts need to have it on the surface working, because right now we don't get a lot of chances to go to the surface of the moon. So you want to try to do this real rigor now on the ground with these prototypes. So you're in a very important realm for us here, because we want to see, what we can do to push things through to the higher TRL levels. And if you go to the next slide, prototypes at NASA are very hardware oriented. You learn a lot by building something and testing it out and pushing it to its limits. So Ray and I are currently in the exploration systems development, and we've had the opportunity to work on many prototypes over the years in the world of trash and also in situ resource utilization. But NASA across the agency uses prototypes all the time to work out these kinks. So we have everything from robotics to gas phase, liquid phase, scaling. And so it's really bringing the hardware and components and subsystems to an integrated unit where you can test it all, see the flow, mitigate your hazards while still proving the functionality. It helps you see, like, where's the thermal load actually forming, or where is the avionics and wiring going to actually get placed, when things are all kit and caboodled to move forward. Can it survive longevity testing for that form fitting function? So these are the types of scenarios we're looking for here with the prototype demonstration. And if you go to the next slide, I believe there's a video, and it can show you some of the progression after prototype. So if you needed to test it in a relevant environment, on the left is a drop tower, in the middle is the 5-second drop tower, on the right is a suborbital flight. So these are things you can, if your prototype is successful at the ground, doing ground testing, the next step is, let's see how it's going to do in simulated environments. You have thermal vacuum chambers you can use. You can do microgravity simulations. There's a lot that would come next. But a lot of this has to be thought ahead of time for your ground testing, but you won't really know until you put it through some of these environmental tests. So while it's not completely a complete requirement to test in lunar conditions for this prototype, we want you all to be thinking about it and considering it to help mitigate that for your next phase if you move on after this prototype test for phase 2. So the next slide is some key elements of prototyping. For this specific challenge, Chris said it earlier a lot, read the requirements for this specific prototype demo. The people crafting this call, we've all put a lot of time into writing those up. If something is unclear, go to that Q&A and ask us and we will clarify. But they weren't AI generated. We put so much heart and soul into writing up those rules. And then begin with the end in mind. Envision that you are just processing one batch of the minimum batch design, and it's only capped at 3 batches. So walk through that. Think about, we are going to have to eventually bring our unit across the country or to a location and set it up and run it. Like, walk through from the beginning to the end and think about getting that one batch or up to 3 batches of trash. And it rolls into number 3. Avoid over design. Remember, this is for form, fit, and function. You can add lots of fancy bells and whistles, but you really just want it to do what you said you would do while following the rules. There's no need to have a lot of add-ons at this phase. We want to see what is feasible, what will be demonstrated, and it will reduce your risk and increase your success for this round of demonstration. 4 is similar. Walk through the entire process end to end. Envision where your pitfalls will be. And if you can, early on in this visionary portion where you're walking through in your ConOps, fail fast and learn fast by walking through it. It might take you more time, but then hopefully that can eliminate some of the pitfalls for later when you actually have your hardware developed. And that even goes to simple things like, this might have to fit in a car or on a van, or what size, don't make this so ginormous you can't even transport it. We have to think about hatch sizes and where we're going to put payloads into spacecraft and how it's going to travel on the road or on a boat or a barge. Like, those are all very relevant discussions to have even though it might not seem relevant to your prototype demonstration, you do have to transport it. So think about all of that while you're designing your prototype. I'm repetitive, but it's so important to fail early and fast and redesign and do it better for next time. So if you have an idea you're not sure about, maybe you can 3D print something real quick and try it out and fail instead of buying that expensive metal part and realizing it doesn't work. So try to be creative and think about how to be more agile in your earlier prototyping. So when you're in your final prototype with us for the demonstration, you can try to avoid and eliminate some of those risks. 6, logistics, demonstration, location, transport, and reassembly. So these are all just kind of remorphing into the same lessons, but it's lessons that we have all experienced in our prototyping over the years. Is yes, you need to have a demonstration on site working, and you can't ignore these logistics of how to get your prototype there, and what you will have available to you. So just keep all of that in mind as you go along. It's cliche, but it needs to be repeated too. Over communicate with your teams. Teamwork makes the dream work. Some of you might just be one person, some of you might be a group, but during prototyping, where designs are rapidly changing and ideas are constantly shifting, one email could save a whole lot of headache later. Maybe you decided to use a different software and somebody didn't know that and they bought the wrong cable that doesn't align with the software language. So many things are important for communication. Document your stuff in a OneNote or some electronic form where everyone can see it. But for prototyping, we have found on our teams that having too much communication is always better. Even if someone likes to work in a silo, have them write all that information on a page where everyone can see it, so that you understand where they're coming from. And positions change month to month, so say your team members shift and leave, you want to have that good communication. And it's the same for us here on the judging side, and you all, again, communicate with us. If you're unsure of something, feel free to reach out and get something cleared up. Don't just assume, we're here as a resource. And then this is listed last, but it should be first. Safety and documentation are very important. You are all going to have the potential for bringing us things that are going to have machines, have rotating parts, have heat, have commodities. I don't know what all the solutions will look like, but hazard mitigation and inventory, in parentheses, see requirements, because it's all there. These are very important for us to understand for the safety of the prototype demonstration and also for your health. So if you are working with exotic materials, make sure you have the right PPE up front. Read that SDS. Understand, because when you come to us to demonstrate, we are going to be looking at the hazard mitigation and inventories to see if you've thought about these, thought through how nothing's going to overpressurize or overheat or expose people to hazardous chemicals. And these are all things you'd have to pay very serious attention to as you climb the TRL ladder to space. You don't want to damage a spacecraft that you're on or a crew that might be nearby if it is a crewed system. So it's good to get into the habit of protecting yourself and protecting where you're going to do the demonstration. So I just gave some examples in that last bullet with compressed gas, rotating equipment, electrical shock, smoke, fire. Are there emissions or off-gassing? Whatever you can think of, try to think about it. Have a sprint with your team or an exercise where you're talking through these different situations and write them all down, because we're going to expect to see that in the documentation throughout your designing. That is my last slide, so I'm happy to hand it off next to Rodney. Thank you.
Thank you very much, Annie. So what I'd like to do is first introduce myself. I'm a Deputy Technical Area Lead at Ames Research Center, and me and my colleague Tom Walters from Langley Research Center are going to cover the value of digital twin development in the context of this LunaRecycle challenge. Next slide, please. Okay, so just running through the key topics that we're going to address is basically just a definition of what a digital twin is first, and then we'll lightly touch on why digital twins are valuable, following up with how NASA currently uses digital twins in a single instance. We have many instances within the agency, but we just want to highlight one. And then finally wrapping it up with when and how to include one in your submission. Next slide, please. Okay, so as you could see from this slide, this is just a small sample, but if one were to do a Google search, you would encounter hundreds to maybe even thousands of definitions of a digital twin. Our predecessor in this role, John Vickers, had sort of a subscription to the famous quote, "When I use a word, it means just what I choose it to mean, neither more nor less," which is spoken by a character, Humpty Dumpty, in Lewis Carroll's novel Through the Looking Glass, which is the Alice in Wonderland series. Now, given that he was the individual to which the introduction of the term digital twin can actually be attributed back in 2010 with a NASA technology roadmap, it's certainly well within his prerogative to take that stance. He also favored Leonardo da Vinci's quote, "A poet would be overcome by sleep and hunger before being able to describe with words what a painter is able to in instants," which I believe appeals to his sensibilities as related to how inspired he was by seeing an online video of a dynamic, physically realistic hyperwall display offering a near holographic representation of a Rembrandt painting of a ship navigating rough seas at a museum in London. Next slide, please. So this video will show what actually that holographic representation of a painting looks like. And while this isn't really a digital twin per se, and it's merely a sort of complicated video, it's what John envisioned a digital twin to be in the future, where we could pair together the physics with simulations shown in this video. Next slide. So there are often various opinions about the distinction between the terms digital model, digital shadow, and digital twin. When I was first introduced to the concept of a digital twin, it was with those three different definitions in mind. Digital model is essentially just a digital representation of something in the physical world without any connections between the virtual or digital representation and the physical world. Digital shadow is fundamentally offering an ability for a connection between the physical and the digital or virtual world, but it's unidirectional. Essentially, it's only a passive collection of sensory information from the physical world to reflect that with what's in the digital world. So with a digital twin, the distinction in the definition between those prior definitions is really a bidirectional interaction. And so really, that is one of the definitions that was shown on a previous slide, and that is shown here, which is one that's taken from the National Academy's report last year, where you could read the last sentence of that really hones in on that bidirectionality aspect. And so that's the one that effectively Tom and I, unlike John Vickers, who didn't coin the term digital twin and have no claim and authority to use that term in our own discretions, we have come to a consensus to view that that is the best definition of the digital twin in that National Academy's report. That's also rapidly becoming the most widely accepted, and it's the one that we're going to use moving forward, in large part due to that last sentence. Next slide, please. Okay, so of course, this is the report that actually I referred to in the previous slide from 2024. There's been a national deliberation on digital twins. And so given that there's so much traction It's due to the fact that there is transformative potential of digital twins and the immensity of what can be revealed. As technologies advance, converge, and adoption grows, digital twins are poised to revolutionize how we work, live, and explore, leading to a more productive, sustainable, and innovative future. In the previous slide, there are different themes that digital twins were shown to be valuable for that show key underpinning foundational technology areas, including ones that our own agency uses in the context of technology foundation areas. So we don't have time to scan through all of those, so I just want to highlight those. And one in particular, if we jump to the next slide, to give a sneak peek at how we're using smart cities today to create digital and smart bases of tomorrow. For example, the building I'm sitting in right now, Sustainability Base, which is sort of patterned after trying to inform how we could use and mature technologies terrestrially to inform how we would use them off planet. As was mentioned earlier on, the Artemis mission, the big idea is to use the moon, a relative near neighbor, to learn and prepare for sending humans to Mars. And so we are already using digital twins to choreograph partners to design, manufacture, test, and operate our systems in a physics-based environment hundreds of thousands of times before fidelity, before we even construct real hardware or attempt real missions. We're also using digital twins for a project, the Lunar Surface Command and Control Interoperability Project, where there's a demo going on right now to show the work that's been done to support communications architectures for the Moon to Mars Artemis mission. That project has a current need to evaluate the performance of networking interfaces across a complex lunar network to standardize interoperability. And a digital twin was created of the lunar environment that is dimensionally accurate and uses system specs to simulate lunar missions as part of a trade study. So there's also a digital twins for cislunar and lunar surface ecosystem development technical interchange meeting, which is the third in a series of many workshops that Tom is going to take a short bit to describe right now. So passing it off to Tom before he jumps back to me.
Okay, thank you, Rodney. My name is Tom Walters. I'm a visual system engineer for the Flight Simulation Labs here at Langley Research Center. I got involved with digital twins through researching the lunar environment for obviously flight reasons. The digital twin for cislunar and lunar surface ecosystem development was a brainchild of not just myself, but also some folks from JPL Aerospace Corporation and Johns Hopkins University. We came together and started trying to pull together interested parties to create an infrastructure that would allow for the interconnection of hardware, software, and environmental digital twins in a digital proving ground concept to support the development of the space economy. So we have universities, government agencies, industry, and international partners that are part of that consortium. There are about 1,000 people that are on our contact list so far. So if anybody's interested, reach out. We'd be glad to include you in our next workshop. Rodney?
Wonderful. Thank you, Tom. So if we could jump to the next slide. All right. So now we're going to cover when and how to include a digital twin in your submission to the LunaRecycle Centennial Challenge. Before I jump in to share what's on the screen here, you could read this yourself, and a lot of this material, of course, has been provided on the website that was referred to earlier. I'd like to share with you a quote from a former deputy NASA administrator, and that's to emphasize the fact that everything that we do on the moon, we've got to figure out how to dispose of it, or it's there forever. So given that motivation, the digital twin component, we're really looking at trying to push the boundary of technology in this second phase. And in spite of the fact that it's an optional submission for both of the rounds for this part of the phase 2 challenge, we want to emphasize that a team's digital twin solution must directly reflect the team's prototype solution that was described previously. The digital twin solution should not be an entirely different system or approach. That's just going to help a lot with offering the level of consistency that is going to be easier for evaluation purposes. So again, with there being 2 rounds in this phase 2, in the milestone round, a team's digital twin has to address a total of 2 scenarios, one nominal scenario and one off nominal scenario. That's the milestone round is the one that has a submission deadline of January 22nd, as shown earlier. In the final round, a team's digital twin must consist of a total of 3 scenarios, one nominal scenario and 2 off nominal scenarios. So there are 3 designated off nominal scenarios with the choice of a different off nominal scenario defined by the team. First is expanded capabilities scenario, where digital twin has to show an expanded capability compared to the demo that the team is going to conduct with a prototype solution in the final round demonstration. Then there is a power outage scenario, where the digital twin has to address the interruption of power during one cycle of the recycling process. And the power outages occur at a point in the recycling process when the process is about 50% complete and remain out for 5 minutes. Finally, the planetary surface operation scenario is where digital twin has to address operation of the prototype solution in either the moon, on the moon, or Mars, but not both. And the operation has to be either inside a pressurized habitat, outside on the surface, or combination of both inside and outside. There's more, of course, details on environmental conditions listed in the challenge instructions. Next slide, please. Okay, so this is the final slide, and with Tom and I representing the digital twin aspect of this challenge. Of course, AI is all the rage lately. We love it. We hope you do as well. But there are some rules around it that I want to just take a short bit of time to make sure everyone is aware of. And basically, it's use and disclosure. AI is permitted in this challenge. And so teams may use AI, artificial intelligence, to develop their solutions and prepare the submissions. And that includes even recent developments in generative AI and large language models, such as ChatGPT, et cetera, are allowed. But we completely acknowledge and recognize that the newer developments, generative AI, large language models, aren't all of AI. When any AI is used to help create any part of the team submission or solution, we ask that that use be documented and clearly stated. Teams are strongly encouraged to carefully review any AI-generated text via Gen AI or graphics to ensure accuracy, credibility, and alignment with the high technical standards of this challenge. Finally, the team's digital twin solution presentation in the milestone round and in the final submission and at the demo should be made by the team leader and our team members, not by an AI agent. So thank you for your time, everyone. I'll now hand it off to Connor from Space Factor, a participant and winner in the previous challenge, who is going to share with you what it means to be a participant.
Hi, I'm Connor McLeod. I'm Vice President of Engineering at Space Factory, and my coworkers are, introduce yourselves.
Hi, I'm Austin Hacker. I'm a Research and Development Engineer at Space Factory.
And I'm Leo Herrera. I'm the Vice President of Additive Manufacturing.
All right, next slide, please. So getting it done at Solver's perspective, I'll just kind of blow through because a lot of this stuff was already covered by a lot of the other participants in this and the panelists. But essentially, this is our hasty observations of how to get it all done and having the energy to do it again, because that's honestly what's the most important thing in prototyping, is to be able to continue prototyping in our mind, right? So next slide, please. So in navigating the challenge, we have these 9 kind of subsections here: building knowledge, formulate an idea, build a team, rally around your mission with your team, test and iterate, meet your milestones, overcome logistics, prepare, execute, share a story. We'll kind of touch on little aspects of each of those and little tidbits of information that we experienced over the course of our time prototyping. Next slide, please. So prototype and essentially the phases, and what Space Factory went through was the challenge of designing. So at first it was design a 3D printed Mars habitat for a 4-person crew, which can be 3D printed using Martian in situ resources as a feedstock. So Space Factory basically completed that in the design phase, as you can see right there, with the Martia. And then basically transitioned into the construction phase, which was started with a raft and then a tub, and then finally the rapid deployment and 3D printed the 1/3 scale prototype demonstrating autonomous robotic operations, which was awarded first place. Next slide, please. So it starts essentially with a building knowledge and formulating ideas. We have in the design phase, as there were a lot of architects on the team at the time, it was kind of like a joint. It started off essentially as a team of architects. That team of architects is augmented by engineers. So the design phase is really heavy on understanding what it took to 3D print a structure, and also kind of providing an architectural vision of what that even looked like, and kind of designing an image around what the actual product is going to look like at the end of the day. So that's in build your knowledge and then formulating your ideas in those two little bullets down there. Next slide, please. In the initial prototype phase, we have essentially so we are talking about building a team, rallying around the mission, testing and iterate, and then meeting your milestones. And in terms of team building, we're talking both externally, internally, and internally. So obviously, in terms of Space Factory, that means like, okay, I build a team by, basically having Austin and Leo on my team, right, and collaborating with us. But we're also talking about external teams. So obviously, if you don't necessarily have a capability, how do you reach out to somebody to provide that capability? And for our collaborators during the NASA Centennial Challenge, it was Autodesk Tech Centers who were working on large-scale 3D printing of lunar regolith at the time, and also Virginia Tech, who also had a machine that was of the same scale and capabilities. That assisted us essentially in providing the final product. And then Techmer is the polymer producer, which basically develops polymer which we use to print. That was, I believe, basalt fiber inlaid. So you can see meeting milestones there. It's the first milestone we met was simply printing, a goo. And then obviously it moves on from there. But all milestones are good milestones if you see it that way, right? So next slide, please. So then the final is essentially the logistics. Like you have got to overcome your logistics challenges. You got to prepare and execute, and then obviously share your story. So this was kind of mentioned earlier. One of the big problems, and especially in the previous NASA Centennial Challenge, and I think I'll speak on this in a second, but it took like a few truckloads worth of pelletized material and all of our equipment to be able to go all the way to Peoria, Illinois, from all the individual locations they were at, right? So the logistics challenge of that and providing the execution of that was almost as important as simply executing it, simply because if you can't get to your final destination, well, then you objectively fail because you might have the best product, but it never sees the light of day, right? So that's kind of how that shaped out there. Next slide, please. So these are just some like lessons learned that we have, and this kind of goes back to, some very basic lessons learned that Space Factory kind of adheres to, and we just talk about a lot, right? So one of them is the 80% rule. Essentially, don't let perfection be the enemy of good enough. Essentially, if we have got like a 24-month project and you're reaching some kind of level, at the 12-month mark, you may reach 80%. It may take you another 12 months to go the other 20%. So honestly, ensure that you can at least make the 80% because 80% is really good. And you kind of have to limit your level of perfect in order to achieve maybe 2 times more great. So next slide, please. Subdivision of task goals and times when done properly yields results. So allocate significant time to breaking up your project into sub goals and subtasks, determining your wants versus your needs. and organizing those sub goals and tasks into cohesive timeline, which is then essentially divvied and given to essentially members of your team, which you then check up and reorganize and reallocate frequently. Next slide, please. It was already brought up before, but the teamwork equals dreamwork rule. So there's obviously many different ways that you can form your team. Space Factory's team is kind of nebulous in that we kind of float around in general around a circle, and then maybe once a week that circle closes up really tight and the particles vibrate together and then puff back out with our goals and our vision of what we're going to accomplish this week. Maybe it doesn't necessarily need to work like that. I think it all is culturally dependent. But everyone has an important role, and obviously everyone should be proud of that role, right? So who's in charge? What does that even mean? Collaborate to make a system where toe stepping is minimal, and then just make sure that everyone is wearing steel-toed boots, so that when somebody's toes are stepped on, you don't take it personally. And then how can you truly take advantage of everyone's strengths and weaknesses and prevent not my job, which in my personal opinion breaches essentially failure within a team, a structure, and organization, right? So next slide, please. So Space Factory, the factory space rule. So Space Factory has a factory space, and our environment is prioritized. And we know as a startup that resources are always constrained. So make do with what you have, be proud of it, and consider it a feature. Take pride in your work, prioritize like-mindedness while encouraging healthy dissent, and put your best foot forward. And also, obviously, united front and a fun atmosphere is half the battle. If you're not having fun doing a challenge, then what's the point of doing the challenge if you're just going to be miserable, right? So we kind of have all these concepts, and I think just here is kind of an example of what we're working on recently. So we wanted to be able to test essentially a mock-up of a vacuum chamber that's at Michigan Technical University. In order to build the mock-up, we decided that we were going to essentially construct this vacuum chamber kind of in a tent ourselves, so that we can test it in ambient here, ship it over into the vacuum chamber to get it tested, in DT vac, right, which is dusty thermal vac. So that is just a kind of idea of what we've got there. So next slide, please. So Space Factory, putting the pro and prototype. And I just one more thing that I didn't mention, I forgot to mention, is that if you guys are looking for resources, right, don't forget that this is a very interesting and cool competition that you guys are working on. And your goals are interesting enough that if you need something and you approach someone, the odds of them saying yes are probably elevated, specifically because this is a cool problem you guys are working on, right? So, in terms of Autodesk, or Virginia Tech or Techmer even, like the fact that we were working on this challenge and our dreams and ideas were big was enough to convince them to want to work with us, right? Not only that, but obviously there's personality traits involved that involves convincing people to work with you. But that's just essentially one big thing that I kind of wanted to throw out there in terms of acquiring funding and resources. So thank you.
Thank you for that. So we know we're out of time, but we're going to stay on for a little bit longer to answer any questions. So please type your questions in the Q&A function, and then we will answer them as we go. And if we don't have time to answer them all, we will be sure to answer them in FAQs. Thank you. I'm going to hand this over to Jennifer.
Hi, everyone.
If all panelists can please turn back on your cameras in case you get a question posed to you. Thank you.
We do have a few questions that we'd like to present to the team. So if I submit my idea and the judges think it's good, what should I do to help my idea get flown on a real NASA mission?
Who wants to take that? Annie Ray or the Space Factory team? Because you guys are all working on this.
Sure. So basically, if you have an idea, so there are several pathways to develop on an idea, right? And I think that there are many programs. There's probably I would assume that this LunaRecycle challenge winds up pivoting into potentially a series of SBIRs or STTRs, right? Or different pathways. There's something called that we actually just were kind of awarded for a similar thing, but it's called a it was ACO, right? Yeah, so we were awarded an ACO, which is essentially a collaboration with NASA in order to provide essentially a shared kind of work space And any work that you can do with NASA obviously puts you closer to your goal of getting something actually flight certified. And obviously, like, there's plenty that has to do with like lobbying and pitching your idea and getting people on board with it. And there's a whole host of things like essentially now having to deal specifically with making sure that you can commercialize your idea and it isn't just being essentially used for NASA's space waste. As space travel itself is kind of pivoting and not necessarily pivoting, but is trying to attract more commercial participants in it, right? So anything that you can do to kind of approach those participants as well and kind of get people on board and as partners also kind of puts you in the right direction for that.
Thank you so much. Are there any tips that you could share on using digital twins? Like, are there specific cloud servers, or how can I share my digital twin?
So I think maybe that question is being directed to perhaps me and Tom. I believe Tom may have had to jump off. And if you read thoroughly through the rules, essentially there aren't any like resources that have been explicitly dedicated to support development of the digital twin. So if there anyone else on a panel who joined in phase one who can offer a bit of insight into any distinction perhaps between the phase one and phase two. But I believe it's most of the participants in the challenge who are putting forth a submission essentially can use whatever resources that they have at their disposal. Doesn't necessarily need to be a particular prescription for that.
Thank you, Rodney. One thing to add to that's tangentially related to what Rodney was saying, but I forgot to make earlier. One of the things we really encourage you to do is there are a lot of organizations out there that are working on digital twins, a lot of experts in digital twins, writing software, this and that, whatever. And then there's a lot of folks out there that are working on recycling technologies or waste management technologies. And we would encourage you to come together. I'm not exactly sure how you're going to find these folks, but they all exist. Encourage you to find those folks and build your teams instead of trying to make sure that each of your team members has expertise in both. So please do try to reach out. The University of Alabama, our allied organization, will send out some information on a LinkedIn group where you might be able to find some of those partners. Completely open to anybody who's interested. NASA and UA won't have any input into who you partner with, but just opening it up for you if you want to post something there. So we'll send out some information shortly on that.
Okay. Does anybody have any tips on raising money to be able to compete?
So I would say that raising money to compete, like I was saying before, I think it's about kind of gaining partnerships, right? So if you know what you want to build, and this is really a crazy example, but it's the one that always kind of blows my mind, right? So there was a small company of a husband and wife working out of an apartment. I think was it New York City? It was New York City.
Yes.
They wanted to bake a cookie in space, right? So they're like, okay, how can we bake a cookie in space, right? How can you get the funding to bake a cookie in space? And what they did was very cleverly found the people that are very into cookies, right? And they wound up essentially teaming with DoubleTree because their whole thing is delivering you a cookie. So I think they got a large portion of their funding essentially from DoubleTree. DoubleTree wound up turning into a feature. And I mean, I'm not sure if there's anything. I'm not saying that okay, go out and find somebody that is equivalent to that, right? But the idea is that you need to get creative as possible, and there are people out there that deal with waste. That would love to be like, we deal with waste. You know what we also do? We deal with waste in space. You know, and you know who deals with waste? Like waste management, right? I mean, not everyone's going to go out and contact waste management, right? But like, let's say that you wanted to partner with waste management, and they have an every one of these like mega companies has like an R&D firm that are working on essentially the next generation of waste management. They may be able to throw in a little bit of their time and a little bit of their money to assist with this with this program in the same way that like Autodesk and Virginia Tech did with us, right? Even TechMart. So this is just like off the top of my head, it's like, okay, the funding is really hard when you just go and ask people for money and you say, I want to do this thing because I might win prize money. But if you are able to pitch it in a way that's like, hey, I want to be able to recycle something in space, waste management, you have the ability to essentially like have your name on this. Like honestly, there's not a lot of recycling or waste management in space, right? And a lot of these companies are into that, right? Because that's their thing. But that's just a for instance, right? Please don't everyone go out and contact waste management. But if you do, tell them I sent you, I guess. I don't know.
Just to follow up on that, also remember that there are prize purses for the milestone round. And so you are able, if you are one of those finalists and you do receive a prize purse, that can help fund your prototype and your digital twin going forward.
What would be considered an over-engineered digital twin? Basically, how detailed of the design does a digital twin need to be?
Oh, okay, that's a great question. You can make it as detailed as you have time and discretionary resources to support. Ideally, all digital twins should be at the highest fidelity to reflect, again, back to one of the slides that I briefed earlier on, as close a representation of your prototype as possible. And so that might require detailed physics-based models. It could use machine learning approaches to support statistical representations of the model. Whatever you think is going to most accurately reflect the prototype at the highest level of fidelity. Again, conditioned on the time, resources that you have available at your disposal to support getting to the level to Space Factory's point at the 80% level, maybe not the 100% level. Hopefully that helps.
Okay. Thank you for all of your questions, and thank you to the panelists. I'll hand it back over to Chris to wrap it up.
So thank you all for participating today and for listening to our webinar. And if you're watching this on the recording, thank you for watching on the recording. Just some next steps, tangible next steps that you can take. One is learn more about the challenge. You could download the challenge rules. You can sign up for updates. We do try to send pretty consistent updates with more and more information. All at the University of Alabama Challenge website. That's lunarecyclechallenge.ua.edu. You can create your team. So the registration portal is open. You can sign your team agreement. You could upload your eligibility documents. You can do all that right now. And that is at lunarecycle.competitionsciences.org, or also linked from the University of Alabama Challenge website. All teams must complete a team agreement to fully register. You are not considered registered until that team agreement is filled out. A template of that is available at our website. Milestone round submissions on the submission platform open on October 1st. So right now you could register your team, you could do your team agreement, you could do your eligibility, and then starting October 1st, you can start submitting your solution. They close on January 22nd, 2026. So we encourage you to go read the rules, figure everything out, get your plan together, and register now and start submitting as of October 1st. And then, of course, if you have any questions, please reach out to us at lunarecycle@ua.edu. As a reminder, anything you send to any of our panelists, any of our LinkedIn or anything like that, we cannot answer. We can only answer from the lunarecycle@ua.edu email address. So any questions that you don't have answered here, we will answer via that email address or FAQs from today. So again, thank you all for your time, and we hope to see your solutions being submitted soon. Have a great day.